Okay, let's first find the formula for f, the derivative. The first derivative gives you, right, if this is x to the power of half, you get half x to the power of negative half. Second derivative gives you negative half square x to the power of negative 3 over 2. Third derivative gives you negative half squared. Bring that down, you get positive this time, positive 3 over 2, x to the power of negative 5 over 2. The fourth derivative, you go back to being negative 3 over 2, negative 5 over 2, or add up negative at the front, x to the power of negative 7 over 2. Okay, so what is a pattern here? Okay, so we have the nth derivative then. So this time the even derivative is negative. So I'm going to put negative 1 to the power of n plus 1. So the even becomes odd. Okay, and we have a half. Okay, there's two halves. So I'm going to factor out one half, and then it's essentially 1 times by, okay, the numerator will be 1 times by 3 times by 5 times by just the odd numbers. Okay, so it's going to be 2n minus 1. And the bottom is just 2 to the power of, you get actually n minus 1. But if you actually include that half, you actually get 2 to the power of n exactly. Okay, so that's the expression that we want. Okay, and we get a x to the power of negative 2n. So if you double this, you get 8, minus 1, you get 7. Double 3, you get 6, minus 1, you get 5. So 2n minus 1 all over 2. So this is your the nth derivative formula. So in there, we got to plug in, because it's center about 16. So we're going to plug in 16. But 16 is 2 to the power of 4. Okay, so we're gonna get okay, so it's gonna be 2 to the power of, if you multiply this 4 into this fraction, we just get a negative 2 times by 2n minus 1. Okay, that'll reduce to just have 2 left, and you multiply in like that. And these two are on a common base. So we have 1 times, 3 times, 5 times, 2n minus 1. You have minus 4n plus 2 and another minus n from the bottom here. So you have minus 5n plus 2. So this is your, right, f, the nth derivative formula. Taylor series is just going to be, right, this, right, just copy and paste this here. Taylor series, and let's test for convergence. So we just have to change the m to m plus 1. You get 1, 3, all the way to, if you just put m plus 1 in there, you get 2m plus 1 instead of 2m minus 1. m plus 1 factorial, and this becomes minus 5 n plus 1, so you get 5n minus 3. Okay, so all of that divide by this, okay, times by 2 to the power of minus 5n plus 2. Okay, that's n there, so that's just going to be x minus 16. So all of this will cancel out with what we have here, except for this last one. All of that and this will cancel out except for this just m plus 1. Okay, and we have 2 to the power of minus 5n minus 3 plus 5n minus 2. So that cancels out and it gives you minus 5. Okay, so this limit here, okay, that n approaches to infinity, we get exactly 2. So we get 2 to the power of negative 4 here. That means x minus 16 is going to be less than, right? If you multiply this both sides by 2 to the power of 4, 16. So the radius of convergence is actually 16.